Today we are going over the Quicksort, and what's quicker than quick? Ninjas. Back when ninjas pillaged villages and conquered cities, ninjas had a tough time of sorting their shurikens after each battle. To combat this issue, ninjas came up with the fastest ninja known method of sorting. The Quicksort. The first step we must do is determine the pivot point. To do that, we take the median and set it as the pivot, which in this case will be 18. So we set 18 as our pivot point, and we swap it with the first index by moving the pivot into the temp variable, moving the 2 and replacing it with the last index, and moving the pivot into the first index. Hot diggity dog! The next thing we do is we set the index and the iterator to the second value in the array. We now compare the value at the index to that of the pivot. 17 is less than 18, but since it's the first value, we do nothing. We now increment the iterator. The value at the iterator is 4, which is less than 18. So we transfer 4 to the temp variable. We set the iterator to the index, and we set the index to the temp variable. We now increment the iterator and increment the index. 95 is not less than 18, so we increment the iterator. 2 is less than 18, so we switch out to a 17 by transferring 2 to the temp, 17 to the iterator, 2 to the index, and we're good. We now increment the iterator once again, along with the index. 42 is not less than 18, so we increment the iterator. 7 is, however, less than 18, so we switch the 7 with the 95 by moving the 7 to the temp, the 95 to the iterator, and the 7 to the index. We now increment the iterator and the index. 63 is not less than 18, but we have reached the end of our array. We now take the pivot and switch it wherever our index is by moving the pivot to the temp, the index to the first index, and the pivot to the index. We can now put the shuriken on the shelf because it is in its proper location. Now that we have two lists, we start with the first one. To do that, we find a new pivot value within the list. For simplicity, we'll start with 17 for the first index. We now reset the index and the iterator to the first list. We compare the value at the iterator, which is 4, to that of 17. But since it's the first value, we do nothing. So we increment the iterator. We then compare that value of 2 to 17. Since 2 is less than 17, we switch out the iterator and the index by moving the iterator to the temp, the index to the iterator, and the temp to the index. We now increment the iterator and increment the index. Now, we take the value of the iterator, which is 7, and compare it to that of the pivot of 17. 7 is less than 17, so we switch the values at the iterator and the index by moving the iterator to the temp, the index to the iterator, and the temp to the index. We now increment the index since we cannot increment the iterator anymore. Since we are at the end of our list, we now switch the pivot with the index by moving the index to the temp, the pivot to the index, and move the temp back where the pivot used to be. Now, since the pivot is in the right location, we can now put it on the shelf. Now that we have an even smaller list, we now need to find a new pivot. So we set the pivot to the first index of the new list, which is the value 4. We then reset the index and the iterator. We compare the value of the iterator to the pivot, but since it is the first value, we do nothing. We increment the iterator and compare that value of 7 to that of the pivot. Since 7 is bigger than the pivot, we do nothing. We have now reached the end of our list, so we switch out the index with the pivot by moving the index to the temp, the pivot to the index, and the temp back to where the pivot was. our list is now in a completely sorted way. So we add our Bradley new sorted shurikens to the shelf. Now we'll go back to our second list. We now need to find a new pivot. To spruce things up, we'll start with the middle instead of the first index. So, 95 will be our pivot point. Since it's not in the first index, we will switch the pivot with the first index by moving the first index to temp, pivot to the first index, and the temp to where the pivot was. Now we reset our index and iterator values. We now compare the iterator of 42 to the pivot of 95. Since 42 is the first variable, we do nothing. So we increment the iterator. 63 is less than 95, so we switch the iterator with the index by moving the iterator to the temp, the index to the iterator, the temp to the index. Now we increment the index. We have now reached the end of the list, so we switch the pivot with the index by moving the index to the temp, the pivot to the index, and the temp to the beginning. We now have sorted our second list, so we may put it on our shelf. And now that we've finished our quicksort, you're ready for your next battle. Looks like it's time to sort out another one. Now we stick to our second list. We will 5 to 5. We compare the value of the iterator to that of the pivot, but since it's the first value, it doesn't really matter. Well, now that we'll go back to our... So the first thing we must do is we need to find where to set our pivot point. Start over. The first thing we do is pick the pivot position. To do this, we take the min and the... Oh my god. And we compare each value in the array to that of the pivot point. Is 17 less than 18? You bet your buns. Now we have split our list into an upper bound and a... So we move 2 to the temp trest. Our shooting adventure was too amazing, so we kind of forgot to introduce the casting members of this film.